The application we're going to use for exploring machine learning is going to be called Mahout. It runs on top of Hadoop, Hortonworks again, and it will use Hadoop and various other tools, HDFS and so on in the cloud system. So you'll be building your knowledge up. Mahout is a sort of standard tool. It's a bunch of packages that allow you to do all of the different machine learning algorithms that we discussed earlier on. And I'm going to give you several examples of how that operates. But first, let's just look at Mahout, what it is. It's, again, a foundation project, and it's a library project in this case. It's a set of libraries that you can call from an interface to do all of this machine learning. Why Mahout? It combines lots of different open source communities together to build a community, to build examples, to provide scalability. So Mahout, if you like, was a community response to the fact that people want to do machine learning, they want to do it on distributed machines. Can you provide libraries to do that? And that's exactly what we've got here. So if you look at this structure of machine learning, you'll find that we have a set of libraries, an application, and an interface. The applications work through the interface, the standard sort of API again, and they will pick out one of these different components, libraries, to do whatever is required. And just to sort of go through those so that you know what they are, we've got genetic algorithms, we've got frequency pattern mining, we've got classification, we've got clustering. Recommenders is when you have people recommending restaurants and you want to rank order those restaurants. You have utilities like Lucene and vectorization. You have mathematical components to this, so that you can do vectors, matrices, and SVDs. You can do collections of systems, and Apache Hadoop is one of the components underneath that you use. So how scalable it is? Well, it's built again with the same principles as the rest of Hadoop. It's as fast, as efficient as it's possible to do using the current technology. It's using a distributed algorithm so that it can scale, and again, the emphasis is not necessarily on providing the optimized best system on a particular machine. It's providing a distributed environment that will do what you want so that you can scale it to any level of actual computation you need and get the results you want. So most Mahout implementations use MapReduce, and work continues to improve Mahout. People are continually adding libraries, different libraries. You can go visit Apache to find out exactly how that's all happening. So let's look at collaborative filtering as an example of what Mahout can provide, and we'll go through different types of machine learning opportunities that Mahout provides, and then after we've done that, we'll go and have a look at specific examples. So this is collaborative filtering. It can also provide recommendations. It's all user-based. It's referring to items. Users are making recommendations about items. There's online, offline support. In the diagram here, what you see is a particular user, Mr. A, and he's coming in and he has his own set of preferences about what he would like to do, eat, see, buy, read. Those preferences are compared with preferences of other users in the system, which come out of a database. Their preferences are matched against his, and then he's provided those set of recommendations. Clustering is yet another application of Mahout. Let's suppose you've got lots of different measurements, XY measurements. They're perhaps let's say ants in the garden, or you could say stars in the sky. And what you want to do is to say they form groups. You would like to classify them as groups. So this might be sort of one sort of galaxy, this might be another, or alternatively this is one set of ants, another set of ants, or whatever you would care to do. Different ways to classify them. The most popular one is k-means. There are k-means based on fuzzy probabilities called fuzzy k-means. There's density-based, there's different types of approaches, but one of the more popular ones is just to take the distance between the points in these diagrams and make a Euclidean measure. So if you're going to go from there to there, what you're going to end up with is square root of the 2 dimensions, it's the Euclidean distance, and use that to indicate if points are close to each other, they exist in one cluster. If this is very large, then they are in different clusters. And so what we can then do, and so what we can then do is to partition this into separate groups. Each of those separate groups would represent some particular property, or perhaps there's some reason why they're all clustered together, and it will give you more information about the data points you have. Another technique is classification. What it does is to put new items into predefined categories. So for example, you might say sports, politics, entertainment. How would you want to classify a particular item? It could be a news item. Perhaps what you do is to look at the keywords in that item and you say, okay, well that's close to sports, so I'll put it in the sports category, or this one's close to entertainment, I'll put it in the entertainment category. It can also build recommenders. If you're going to go and say, well, I want to see all the sports news, then it will be able to recommend what to look at from the news point of view. Lots of different implementations you can make on that. There's naive Bayes, complementary naive Bayes, decision forests, linear regression, and so it has classification techniques to do all of these. And last, frequent pattern mining. Here we've got shopping cart. You go and you're going to buy things. What we can do, identify, is what people actually sort of typically buy. So they might just go in and buy milk, bread, cheese, and then they might have some extra items around it. Trying to identify what are the common items. So if somebody buys bread, then you could offer them milk and cheese, because you know most people do that. That can be very helpful to the person's reminder of what to buy. It can also sort of speed things up. It can do a great deal of optimization in where you place the milk, bread and cheese in the supermarket. So a lot of different benefits. So here we got several different patterns, several different techniques, all provided by Mahout. And now what we're going to do is look at an example.